Let's dive into the first two components of CLV, which is size of wallet and share of wallet. And let's probably start by explaining again what these two measures actually mean, and also why in many settings it can be very challenging to obtain the information necessary in order to calculate them. Assume we are in a market where there are only three customers, customer 1, customer 2, and customer 3. And there are three companies who sell on that market, company A, company B, company C. It could also be one company who sells different brands, for example, brand 1, brand A, brand B, brand C. On the top left corner of this slide, you see how much money each customer spends on each company. Customer 1 spends $10 with company A, $30 with company B, and $20 with company C. Customer 2 spends 40, 20, 40, and customer 3 spends 20, 10, 10. Usually, we are interested in a company or brand perspective, which means that usually we sum up these values by row. 10 plus 40 plus 20 gives 70. 30 plus 20 plus 10 gives 60. And 20 plus 40 plus 10 gives 70. 70, 60, and 70 is the total amount of money that the companies A, B, and C make with all customers in the market. So it's equal to total sales. If we sum it all up, 70, 60, and 70, we get to 200. And if we divide the total sales by the 200, we get market shares, 35, 30, and 35. Now in CRM, we are not interested in the company logic, we are interested in the customer logic. So instead of summing up by rows, we sum up by columns. 10 plus 30 plus 20 is 60, 40 plus 20 plus 40 is 100, and 20 plus 10 plus 10 is 40. 60, 100, and 40 is the size of wallet. You will see that if you sum up all the size of wallets, you come to the same 200 that you got when you summed up all the sales. And this makes sense because in this example, anything that is sold by a company has to be purchased by a customer. Very similar how you can divide sales by market size to get market share, you can divide size of wallet by market size to get share of category requirements. But we are interested in something else. We are interested in the share of wallet of customer 2, for example. Look at customer 2. Customer 2 has a size of wallet of 100, and customer 2 spends 40 with company A. If you divide the 40 by 100, you get 40%, which is just the share of wallet. Now, the problem with this approach is the following. Assume you are company A. It is probably feasible that company A can find out how much money they sold to different customers in the market. Although, if you are a fast-moving consumer goods company who doesn't sell their products directly, but sells products through retailers to customers, already this step can be very, very challenging. But let's assume for the moment we are Amazon. Amazon can relatively easily tell you how much money they made with each of the customers. But Amazon does not know how much money customer 1, 2, and 3 spent on their competitors, which means even if Amazon, assume Amazon is company A, were able to get the 10, 40, and 20 to populate the first row, they don't have the information for any other row. How can you obtain the information needed in order to calculate size and share of wallet? This is what we focus on now. And we split between two different settings, whether we are in a B2B or in a B2C setting. If we are in a B2B setting, one thing that we can do is we can try to come up with an approach to guess how much money our customer spends on the entire product category. Let me give you an example. Assume we are at Lenovo and we produce laptop computers, and we want to find out how much money a company like LVMH spends on laptop computers per year. One way we could do this is the following. We could say, if we knew the number of employees that LVMH has, times the number of laptops they buy per employee in a given year, for example, times the cost per laptop, we would have a rough approximation of how much money they spend on laptops, right? If they have 1,000 employees, they buy on average 0.5 laptops per employee per year, because everyone has one laptop, but they usually keep them for 2 years. So it's half a laptop per employee per year on average. 1,000 times 0.5 is 500. And if then a laptop costs $10, the total amount of money they spend on laptops would be $5,000. And we can then take whatever we sell them in terms of laptops, divided by the size of wallet to get a share of wallet. This approach you might have seen in a completely different setting, namely in recruiting interviews, where occasionally you get asked brain teaser questions. Estimate the market for light bulbs in Australia. How many people were red in New York on a given Monday? And the approach for these brain teasers and for market sizing in B2B is essentially the same. What you need to do is you need to come up with a very easy expression, a kind of equation as you have it here in the first bullet. But this equation shouldn't be too long, nor should it be too short. If the equation is too short, you don't include enough input parameters, and then the result may not be very accurate. But if it is very long, if it includes lots of factors that you need to multiply, then each of these elements needs to be collected in terms of data. And since you can collect none of them with perfect accuracy, the errors in all these measures may accumulate and the results may also not be very accurate. So you need to find the right balance between getting in enough information, but don't overdoing it. And this is a very specific decision for every specific case that you have to do. Now, the reason we have to do it like this in B2B is that in B2B, we are dealing with professional purchase managers on the side of the buyer. And these people are very aware of the type of information they can and cannot share with their suppliers. In B2C, the situation is much easier because in B2C, consumers usually have only a very limited understanding of the type of information that they can share. So let's now focus on the next couple of minutes on how to do this in a B2C setting. Assume we are Amazon and we want to find out the size and share of wallet of a certain number of customers buying books at our store. We assume we are only selling books for the moment to make it easy. We have, as Amazon, a very large number of customers. Probably we have 10 million customers. And for all of these 10 million customers, we know a lot of information. We know where they live based on their zip code. We know which type of credit card they use, which type of products they usually buy, whatever type of information there is in our database. So it is a very large list of characteristics that are available for all customers. What we do now is, out of those 10 million customers we have, we take a relatively small sample, 1,000, 5,000, 10,000 customers. And this sample, we ask the following 4 questions. First, where did you buy a book last time? Next, where will you buy books next time? Third, how often do you buy books? And last, when you buy books, how much money do you spend? I'll show you in a minute how the answer to these 4 questions can help you to calculate size and share of wallet. But the problem is that you only get size and share of wallet for those customers where you actually asked the questions. So for those 1,000, 5,000, 10,000 customers. So once we have asked those customers the questions and calculated size and share of wallet, what we will do is we will try to find out using statistics whether there is any form of relationship between the information we know about everyone and the size and share of wallet we only know about a few. Maybe women tend to have a certain share of wallet that is higher than the one of men or lower than of men. Maybe people living in a certain area of a city tend to have a different share of wallet. People who tend to buy certain books in the past have a certain different share of wallet. Those of you who know statistics, what you try to do is you try to run a kind of regression where you put in all the variables that we know and try to use them to explain the size and share of wallet that we only know about a few customers. And if it works out and we get a model that works reasonably well, we can then use this model to guess the size and share of wallet for all those customers where we didn't send the questionnaire to. But before we can do this, obviously, we need to combine the answer to these 4 questions in order to calculate size and share of wallet. So let's look how this can be done. The first customer we ask is Sandy. And Sandy tells us that the last time she bought books was at Amazon. And the next time she will buy books, she has a 20% chance of going to Amazon, a 45% chance of going to Barnes & Noble, and a 35% chance of going to Fnac. We now put this in a table. The column shows where she went last time, and the rows shows where she will go next time. Since the last purchase was at Amazon, she goes into the first column. And since the next purchase will be 20, 45, and 35%, these are the values we put into that column. We do the same for Bob, who has his last purchase at Barnes & Noble, and for Stephen, who had his last purchase at Fnac. Bob goes into the second column, and Stephen goes into the third column. Of course, we would ask many, many more than 3 customers. So in this case, what goes into the first, second, and third column is the average of the answers that all those customers give us who purchased last at Amazon, Barnes & Noble, and Fnac. What you have here now is a table, a matrix that tells you what people probably will do the next time they buy, given what they did the last time they purchased. It tells you how people switch between brands, and this is why you call this a brand switching matrix. You can use this brand switching matrix to predict what people will do in future in the following way. In period 1, Sandy purchased at Amazon. We know this because that's what she told us when we asked her. In period 2, we know that Sandy has a 20% chance of going to Amazon, a 45% chance of going to Barnes & Noble, and a 35% chance of going to Fnac. We know because that's what she tells us. Now, what happens in period 3 depends on what happened in period 2. If in period 2, Sandy went to Amazon, the values for period 3 are 20, 45, and 35%, which is just the first column of the matrix. If in period 2, Sandy went to Barnes & Noble, we use the second column of the matrix. And if in period 3, she went to Fnac, we use the last column of the matrix. And then we simply multiply out. 20% times 20% is 4%. And 4% is just the probability that Sandy goes to Amazon in period 2 and to Amazon in period 3. 20 times 45% is 9%, which is the probability that she goes to Amazon in period 2 and to Barnes & Noble in period 3. If you do this for all the 9 cases and you sum up those probabilities, you just come to 100% because this spans up the entire universe of options that Sandy has. Now, if we want to find out what is the chance that Sandy ends up with Amazon in period 3, you have to add the 4, the 11.25, and the 15.75, and we come to 31%. Now, you may say, this doesn't make any sense, because this assumes that the answers that Bob and Stephen gave us on the previous slide can be used as possible answers, as possible futures for Sandy. And you're right, we assume that whatever Bob and Stephen tells us is like what Sandy would have told us if she had been at Barnes & Noble and Fnac in the last period. Maybe this is wrong, maybe this is not wrong, but it's the only information we have. And on the next slide, I show you an approach how you can test how wrong this information is. But for the moment, I'd like you to pause this video, probably watch it again in order to understand how the probabilities for period 1, 2, and 3 have been calculated. And of course, technically, we could now do exactly the same approach for period 4, 5, 6, and 7. Now, those of you who are good with mathematics, they know that what we essentially do is we multiplied this brand switching matrix multiple times by itself. So that you can also look at matrix multiplication using Google or YouTube, and you would find different ways of how this can be done. But the point is, if we did this over and over again for period 4, 5, 6, 7, we would see that the long-term value that we get for Amazon, the long-term probability that Sandy ends up with Amazon in period 3, 4, 5, 6, tends to become always the same. And it's always roughly 31%. 31% is the probability that in the long run, in any future period, Sandy ends up with Amazon, which is just her share of wallet. Now, obviously, the problem that we have is that we don't know how accurate this number is. But we also have 2 other questions that we didn't use. So let's use them now. We know from our database how much money we made with each of these customers. We know that we earned $60 with Sandy per year, $200 with Bob, and $1,500 with Stephen. Now, for the other 2 questions that we didn't use yet, Sandy tells us she buys on average 5 times books a year, and every time she buys books, she spends $20. 5 times 20 means she should spend $100 on books per year. We just calculated on the previous slide that 31% of this amount should go to us, which means we should see sales of $31. But what we actually see is sales of $60. There is a huge gap. The calculated share of wallet is 31%. That's what we did on the previous slide. But if we take the actual sales that we make, the 60, divided by the answers she gave us to the last 2 questions, the 100, we get to 60%. And now we have to decide what we do. Option 1 is that we say, listen, the assumptions that we made on the previous slide are just not working for us. We cannot use what Sandy, Bob, and Stephen did interchangeably for another. And then we use a different approach to calculate share of wallet. If you want to do this, I refer you to the reference that I gave you on the previous slide, which explains in more detail how this could be done. Another option is that we make this process for 5,000 customers, and we find out that it works for nearly everyone except for a handful. Well, if this is the case, then probably it's easier to keep the approach that we have, delete this handful of customers as outliers, and use the model that works for most people. Now, an interesting question that you can ask is, why do we even bother with this? Why should we calculate size and share of wallet? Well, let me finish this section by giving you a last example. This is the customer database of a bank. This customer database of a bank has been split into 25 groups, depending on whether the share of wallet is 0 to 20%, 20 to 40, 40 to 60, 60 to 80, or 80 to 100, and depending on whether the size of wallet is in the top 20%, the top quintile, or in the bottom 20%, the bottom quintile. The size of each bubble tells you how many customers you have in a given segment. What this, for example, tells you is that the number of customers that is very, very high value, customers who have a high size of wallet, so we are high in the metrics, and who have a high share of wallet, so the top right, is very small. There's only 0.8% of all the customers who have a share of wallet larger than 80% and are in the top quintile in terms of size of wallet. Another thing that this slide tells you is, look at the colors. The yellow bubble is always the one that is largest in any given row. And you see that for all those customers where the size of wallet is in the second, third, fourth, or top quintile, the largest bubble is always in the first column. This means that customers who have a reasonably large size of wallet, they tend to split their business across multiple companies. And we see this again in a couple of sessions when we talk about loyalty program and where we talk about monogamous versus polygamous customer relationships. Now, what can you use this matrix for? Well, in order to use it, probably one way to do it is to simplify it a bit. So instead of working with 25 groups, we only work with 4 groups by summing up the top right, top left, bottom right, and bottom left corners. And we would get to this. The top right corner are our most valuable customers. They have a high size of wallet, they have a high share of wallet, they're about 5% of them, and we maintain and guard them. In the logic of CRM, this is the top of our pyramid. The bottom right, 17.3% in this case, has a very high share of wallet, but not a large size of wallet. These customers we try to hold because they are loyal to us. They simply don't spend a lot on the product category right now. Maybe they are very loyal to one specific airline, but they don't travel that much. Well, one strategy that we can have is we can hold them in order to hope that if at some point in future they start to travel more, they will still be loyal to us and then move up into the maintain and guard quadrant. The ones on the top left, 35.1%, they have a high size of wallet but a low share of wallet. These customers we can target for additional selling. We can send them direct marketing messages, for example, in order to convince them to spend more of the money they already spend on the category with us. They already travel a lot, but currently they spend a lot of money on British Airways and not so much money on Air France. Now we can run a specific promotion for them to convince them to spend more money on Air France, for example. At the bottom left corner, which is 42.7%, are customers who have a relatively low share of wallet and a relatively low size of wallet, and those customers we just keep. I talked to you on the previous slide when we talked about CLV that very often companies may actually only start with recurring revenues. And this is correct. You do not need to calculate size and share of wallet if you want to calculate CLV, especially not if you already have revenue. But hopefully these slides have shown you that calculating size and share of wallet is not rocket science. And hopefully they have also shown you that this information can be very valuable. But now let's focus on the next point, which is customer lifetime.